Hello guys and welcome back to the show. One of the topics that I've struggled to understand in the past is Kubernetes. But over the past few weeks, I've spent some time learning about it, and today I would like to share with you all what I've learned so far. We will be looking at what Kubernetes is. We will then go ahead and build a simple Node.js application which we will deploy with a Kubernetes deployment object using Docker as the container runtime. So let's get started. I guess the first question is, what is Kubernetes? When you read documentations and blog posts on the internet, they say that Kubernetes is an orchestration tool for containerized cloud-native microservices. But this is really confusing if you're just getting started. So let's break this down using simple terms. When they say that Kubernetes is an orchestration tool, what this basically means is that when we create an application like an Hello World app, we can use Kubernetes to deploy and manage this app. Deployment means that Kubernetes takes the Hello World app or service and pushes it to a production environment so that people around the world can see and use this Hello World app. Managing means that Kubernetes will ensure that the Hello World app is always running, and if the Hello World app gains attractions and billions of people try to access it, Kubernetes will ensure that the app is able to scale and handle the load. This is what they mean by Kubernetes is an orchestration tool. It means that Kubernetes will basically deploy and manage our apps for us. Containerized means that the application is run in a container. If you do not know what a container is, then you can have a look at my tutorials on Docker. But essentially, when we create an app that prints Hello World, we can create an image of this app, and an image is basically a reflection of the app using a container runtime like Docker. And then when we run the image, we get a container. So essentially, a container is a running instance of an image. Lastly, cloud-native microservices are applications that are built from small specialized parts. You can think of them as a puzzle. A puzzle is made up of small individual pieces, but when the pieces are brought together, they form the actual puzzle. That is basically what microservices are. They are standalone applications that communicate and come together to form a meaningful application. And these applications are designed to meet modern business needs such as auto-scaling and self-healing. Auto-scaling means that when the application attracts lots of traffic, the application is able to create instances of itself so that it can handle the traffic. Self-healing means that if the application goes down, it is able to come back up. Now that we have an understanding of all these terminologies, we can say that Kubernetes is a tool used to deploy and manage applications that are packaged and run as containers. Now, let us have a look at the Kubernetes cluster and the components that make up Kubernetes. Kubernetes is made up of masters and nodes. But the question is, what is a master and what is a node? In the world of Kubernetes, masters are the brain of the cluster. They are also sometimes called the control plane, and they make all the deployment and scheduling decisions. Basically, they decide what should happen in the cluster. As you can see in the diagram, the control plane is made up of something called API server, cluster store, scheduler, and a controller manager. There is also something called a node. A node is basically the thing that does the actual work in the Kubernetes cluster. And it is made up of something called a kubelet, container runtime, and network proxy. We will look at what these are in details. Now let's talk about the components of the control plane. As we saw, one of the components is the API server. You can think of the API server as the front end of the Kubernetes cluster. All communications between components must go through this server. It basically exposes public REST API interface to the cluster so that users like you and I can interact with the Kubernetes cluster. I stated that Kubernetes is used to deploy and manage containerized apps. But obviously, we need to specify a set of configurations so that Kubernetes can use these configurations to manage the app. We do this usually by creating something called a manifest file, which contains the desired state that we want Kubernetes to use. And this is actually sent to the cluster by posting it to the API server. We'll have a look at this, so don't worry if you don't understand, but I just wanted you to know that the API server is basically the entry into the Kubernetes cluster. Now let's look at the cluster store. The cluster store is the only stateful part of the Kubernetes cluster. If you remember, when I talked about the API server, I stated that we can post some YAML configuration files containing the desired state that we want our Kubernetes cluster to have, right? We can post it to the API server. Now, once this is posted, it is authenticated and persisted in the cluster store. So in short, the cluster store is where we actually store the configurations for the Kubernetes cluster. So no cluster store, no cluster, because we will not have the state for the cluster. The next thing that we can talk about is the controller manager. Now, once the desired state has been stored in the Kubernetes cluster, there are some background watch loops that are in the background constantly watching the API server. Essentially, they look at the desired state, so the state that we specified in the YAML file that was posted to the API server, which is currently stored in the cluster store. This state is constantly being watched, and if anything changes, the control loops will basically work to reconcile the changes to match the desired state. And these control loops are basically controlled by the controller manager. So for instance, if the desired state was to have 1 and 2, and for some reason the 1 and 2 changed to 1 and 3, what the watch loops will do is that they will work to change 1 and 3 back to 1 and 2. And these watch loops are controlled by the controller manager. The last component of the control plane is the scheduler. At a high level, the scheduler gets work from the API server and assigns them to nodes. And I said earlier that nodes are the one responsible for doing the actual work in the Kubernetes cluster. Behind the scenes, what the scheduler actually does is that it will get all the nodes inside of the cluster, it will filter these nodes, and then it will select nodes that are healthy and then assign them work. When I say healthy, I mean nodes with enough resources that are able to execute a task. So it will look for these nodes and then it will assign them work, and these nodes will be the one actually doing the work in the Kubernetes cluster. Now let's look at nodes. Nodes are workers in Kubernetes. They are responsible for doing the hard work in the Kubernetes cluster. The components of nodes are the kubelet, container runtime, and network proxy. When a new node joins the Kubernetes cluster, a kubelet is installed onto the node, and this newly installed kubelet is responsible for registering the node with the Kubernetes cluster by pulling the resources of the node, so the CPU and the memory, and adding it to the wider cluster pool. So essentially, they are responsible for registering node to the Kubernetes cluster and then executing work. Now let's look at container runtime. We said that Kubernetes is used to deploy and manage containerized apps. In order to deploy and manage the containerized app, we need a way to manage or perform the container related tasks like pulling image, starting and stopping containers. This is done by the container runtime. It must be noted that Docker is not the only container runtime used in Kubernetes. There is another one called Containerd, and there are others as well. The last piece of the puzzle is the network proxy. At a high level, what the network proxy does is that it ensures that each node in the cluster has its own unique IP address. And that is basically it. We now know what masters or control planes are, and we also know what nodes or workers are. The last big piece of the puzzle is what we call pods in Kubernetes. To package apps for Kubernetes, we essentially need to package the app as a container, wrap the container in something called a pod, and deploy it using a manifest file. So the question is, what is a pod in Kubernetes? You can think of a pod as a namespace in which we put the containerized app so that we can deploy it. The truth is that we can't run containers directly on Kubernetes cluster. So we need to put the containers in this namespace called a pod. So you can think of a pod as another container or box in which we put our container so that we can run the container inside of Kubernetes. It must be said that we can have one or more containers in the same pod. Usually, when there are multiple containers in the same pod, it means that the containers are coupled together and they need to share the same resources. If multiple containers are run in the same pod, they will share the pod's address, namespace, and memory. It is advisable, however, to have one pod per container. Pods are also the unit of scaling. So when we want to scale in Kubernetes, we do not scale the individual containers, rather we scale the pods. Pods can also die. When a pod dies, it can be replaced by a new pod, and this new pod will have its own unique IP address, which is different from the old IP address of the pod. So it is not advisable to store state inside of a pod, because if a pod dies, you lose that state. So now we know what Kubernetes is. We know that the Kubernetes cluster is made up of masters and workers, and we also know what a pod is. There are a few more things that we need to learn, but we actually learn them when we start using Kubernetes. So let's jump into VS Code and create an app which we can actually deploy using Kubernetes. Remember that in this tutorial, we will use Docker as the container runtime. What we are going to do is to create a simple Node.js application, Dockerize this, and then deploy this using Kubernetes. Inside of the terminal, make sure that you have Node.js installed on your machine. You can check this by typing node-v, and as you can see, I've got Node.js 14.17. Now, I have Node.js installed, so I'm going to go ahead and create an npm package using npm init-y, and this should create for me a package.json file. So if I do ls, as you can see, I've got a package.json file. What I'm going to do is to install express.js as a dependency inside of the package.json file. If you go to the express.js documentation, what you can do is to just copy this, okay? Go back to the terminal and then do npm install express. Now that I have express.js installed, what I'm going to do is to create an app.js file. Inside of the app.js file, I'm going to go on the express.js documentation, go to getting started, hello world, and then just copy this. Go into the app.js file and just paste it here. And that is all I need for now. So I'll go ahead and start the server and make sure that it is actually working. So I'll go back to the terminal. In the terminal, all I need to do is to type node and then app.js, like so. And as you can see, it says that it is listening on port 3000. So I'm sure that if I go on port 3000, I should be able to see hello world. And as you can see, on localhost port 3000, I have hello world. So we're going to now Dockerize this app, okay? To Dockerize this app, what we are going to do is to create a directory called Docker. So I'll say mkdir Docker, like so. And inside of this directory, I'm going to create a Docker file. So I will say touch, like so. Now, inside of this Docker file, what I'm going to do is to go in the Docker documentation under get started. What I'm going to do is to copy this, okay? Just copy this. So click over here. You can actually find the link to this page in the video description. But what I'm going to do is to copy this, go back into my Docker file, and then I'll paste this over here, okay? Like so. The next thing that I need to do is that I need to change this. If you're using yarn, you can use yarn, right? But I'm using npm, so I'm going to change this to npm. I'm going to get rid of the -- production, and then inside of the command is node and then app.js, because our file is called app.js. If you created a directory which contains your app.js, you need to specify the path. But since mine is just app.js, I'm just going to do app.js like this. And that is basically it. I have created a Docker file, and if I run this, it will create for me an image of the application. So this application that I've created over here. Let's actually run this and let's see if it actually works. What I'm going to do now is to create an image of the Node.js app that we just created. If you are not too familiar with Docker, I've got a tutorial on this channel. You can go and watch that before progressing further with this video. So I'll go ahead and create an image. I'll create an image by using this command. Docker build.-t is a tag, which is the tag of the image. So my image will be called my app, and then I've specified the path of where the Docker file is. So I will just run this, And this should basically create an image for me, as you can see. Now, if I do Docker images, as you can see, I have an image which was created 15 seconds ago called my app. Let's run this image to get a container. To run the image, I will say docker run -p 3000 3000 and then the name of the image. The -p flag is to map the port which was exposed inside of the container to the host. Okay, so -p basically maps this port, so the port which is inside of the container, which is port 3000, to my computer's port 3000, so that I can basically connect to the container from my computer. So I'll go ahead and then hit enter, like so. And as you can see, it says listening on port 3000. So if I hit enter, it should still run. And as you can see, it works. What we are going to do now is to install Kubernetes and then use Kubernetes to manage and deploy this service. We will be using Kubernetes provided by Docker Desktop in this tutorial. I already have this installed, but if you want to use Docker Desktop Kubernetes, all you need to do is to go to your settings, then click on Kubernetes, click on enable Kubernetes, and then click on the apply and restart. That's all you need to do in order to have Kubernetes installed. Once you have that installed, you will see that you have Docker and Kubernetes running on Docker Desktop, as you can see on my screen. The last thing that we need to do in order to start using Kubernetes is that you need to go to Docker Desktop, go to Kubernetes, and then select Docker Desktop over here, like so. Once this has been done, you can go to the terminal and then type in kubectl get nodes. If you see this, it means that everything is working for you and you're good to start. The command that we just used, kubectl get nodes, basically gives us the nodes inside of the Kubernetes cluster. And as you can see, we only have one node, which is the control plane or the master, the one that we talked about earlier. If I do kubectl describe nodes and then the name of the node, like so, as you can see, I get some information about the node. The name is Docker Desktop, the role is the control plane, and then you can see the resources that it currently has. I'll not worry too much about this, but I just wanted you to know that you could use this command, kubectl describe nodes, to get more information about the nodes inside of your cluster. Now, if I do kubectl get ports, as you can see, it says that there are no resources found in the default namespace, which means that there are lots more namespaces available. So if I do kubectl get namespace, there are other namespaces, but what we are going to do is that we are going to work in the default namespace. We are going to actually create a deployment object and then deploy this in the default namespace. Let's see how we can do that. From the roots of the Node.js application, I'm going to create a directory called K8. The name could be any name that you want, but I chose to call mine K8. Instead of this K8, I'm going to create another directory called deployment. Inside of this deployment directory, what I'm going to do is to create a file called deployment.yaml. Remember, when I talked about the API server, I said that we create a desired state, and this is the desired state that Kubernetes will use to manage our cluster. This deployment.yaml file will contain the desired state that we want Kubernetes to use to manage our application. So I'll go ahead and create this YAML file or manifest file, whatever name that you want to call it. In order for me to get assistance when creating the deployment object, what I'm going to do is to install this plugin called Kubernetes. And then I'll go to my deployment.yaml file. Now all I need to do is to type deployment like so, and I get everything for free. Now let's try and understand what we have over here. We have something called the API version, and as the name suggests, it defines the version of the schema. There's another thing called kind, and the kind is the deployment that we specify. Under metadata, we have a name. This name is the name of the deployment. I'll change this name to my app deployment. Before I talk about this, let's look at the containers. I have a container name called my app, and as you can see, I need to provide it an image. Currently, my image has not been pushed to Docker Hub, so I need to hard code the name of the image over here. To get the local image, just type in Docker images in your terminal, and the name of mine is called my app, as you can see over here. So I'll copy this my app and then paste this over here. When the deployment is run, Kubernetes will try to pull this image from the Docker registry. But since we do not have the image over there, it is going to fail. So I will specify under image pull policy, I'll set that to never. This is to ensure, again, that the image is not pulled from the Docker registry because I do not have it there. And then for container port, I'll set this to 3000. Now let us have a look at the spec. Underneath the spec, we can specify the number of replicas that we want, i.e. the number of ports that we want inside of our node. So we can specify the number of ports that we want created in the master node. So I'll go ahead and specify 2 for now. Again, what this means is that we will have 2 ports. The ports will contain containers, and these containers are a running instance of our Node.js app. Underneath the spec, we also have labels, which means that our ports will have these labels attached to them. And the labels are very important because they are used by another Kubernetes object called services, which we'll look at later. But for now, I think we are good to actually deploy this and see if everything works as expected. Now, let us try and send the YAML file to the cluster store. You remember when we spoke about the API server, I said that we create a YAML file and then we post this YAML file to the API server. Some authentication and verifications are done. Once these are successful, the state is stored in the cluster store. So what we are currently going to do is to post the YAML file to the API server. And we do this by saying kubectl apply -f and then the path to the YAML file. And the path is basically k8 deployment. And as you can see, it says that deployment has been created. So if I do kubectl get deploy, it says that I have my new app development ready is 2. So I have 2 ports and all the 2 ports are ready and they all have the up-to-date state. So they all have the desired state that I want. So if I do kubectl get ports, as you can see, I've got 2 ports running. If I want to get more information about the ports, what I can do is that I can type in. So over here, we can see the name of the port, the status is running, and then the node is the master node. If we want to get detailed information about the port, we can use the kubectl describe port and the name of the port to get some more information. And as you can see, I have a bit more information. These are the logs. We can also see the container ID and the image that was used and then the port that is running on. Assuming that I wanted to scale my application, what I could do is to just come over here and remember that the unit of scaling in Kubernetes is the port. I could just increase the port to, let's say, 10. So I could come here and change the replicas to 10. In order to apply this, all I need to do is to go back to the terminal and then run the kubectl apply -f and then specify the YAML file like so. Like I said, there are some watch loops which are always looking at the state, the desired state, and then the current state, and then they reconcile. So if I do kubectl get ports, there are some few more ports which are currently starting up. Some are pending because they are not ready, so they are pending, and others are running. If you give it a few more minutes and you check, you see that everything is running. And if I check kubectl get deploys, I can actually see the number of ports which are currently ready and available. Now let's say that I wanted to scale down. I could do the same thing by going back to the deployment.yaml file and then run the command again. If I do kubectl get ports or kubectl get deploys, you can actually see that now I have 2 ports running. If you do not want to scale down or up using the deployment, you can actually do it imperatively through the command line. I could just go to the terminal and say kubectl scale deployment, the name of the deployment, and then the number of replicas that I want to scale to. As you can see, it has been scaled. Okay, so if I do kubectl get deploy, as you can see, it is 0. And if I do kubectl get ports, the status of the ports basically says that terminating. Let us scale this back up to 2. Our Node.js app is running inside of a pod in a Kubernetes cluster, but there is no way to access the Node.js application from my browser. If I go to the browser, and I go on localhost port 3000, nothing is working because I do not have access to the containers inside of the port. But I am 100% sure that these containers are running inside of the ports because I can check the logs. If I go to the terminal and I type in kubectl logs and then the name of one of the ports, it says example app listening on port 3000. But again, we cannot access this from the outside. If we SSH into the node, so the master node, and we make a curl request to port 3000, we will be able to access the service from inside of Kubernetes. But from the outside, we will not be able to access the service. So we need a way to be able to access our Node.js app from inside of the ports. The way to do this is by using something called services. And apart from helping us to access the containers which are running inside of our ports, they also add stable networking and load balancing to our ports. When we spoke about ports, we said that ports can die. So it is not wise to basically connect to a port by using the port's IP address, because when the port dies and a new port is created, that IP address which was previously being used will be useless, because the new port will not have the IP address. This is solved by having services. With services, we have stable and reliable networking to apps deployed on Kubernetes. I don't want to go too much into details into how services work, but what I want you to take out from this is that services add stable networking and load balancing to ports. They provide load balancing and a way to access containers running in the port from the outside of the Kubernetes cluster. And just like deployments, services can be created in a declarative way. So we can create a YAML file, and rather than providing the deployment object, we can provide the services object. Let's see how we can do this. Inside of the K8 directory, what we're going to do is to create another directory called service. And then what I'm going to do next is to create a YAML file called service.yaml. Like so. Navigate to this directory, and all I need to do now is to type service. The API version is version 1. The kind is service. The name of the service is called my app service. Port that will be exposed by the service is port 3000. The target port is also 3000. And then I need to specify the service type. So what do I mean by service type? If I go to the terminal and I type in kubectl get svc, as you can see, I have one service. The service is called Kubernetes and the type is the cluster IP. So the cluster IP is the default IP address, and it will not allow the service to be accessed from the outside. What we need is the node port. The node port basically builds on top of the cluster IP address and adds a cluster-wide TCP and UDP port. It makes the service available outside of the cluster on stable ports. So inside of the service.yaml file, I'm going to specify a type, and this type will be node port. And then I'll specify the node port. So under port, I'll specify the port of the node port. So I'll say node port, and I'll give this port 30,050. One thing that I need to mention is basically this selector called my app. To understand what selector app my app is, we need to have a look at this. As you can see on the service, there is something called env, and on the ports E and F, there is another thing called env. Basically, the service has to know which ports it has control over, or the ports that it needs to give stable connection to, because inside of the Kubernetes cluster, there could be nodes with lots of ports, and we could have more than one service. So how does a service know which port it should give stable connection to? It does that by using the labels that we provide for each port. So over here, we are saying that, hey service, any port which has got a tag or a label called env, give a stable connection to that port. If a port hasn't got the env label, the service is not going to give a stable connection to that port. Inside of our deployment.yaml file, we specified under labels that app is my app. So all the ports will basically have this label called my app. Inside of services, we are selecting all ports which have got that my app label. That is basically what this selector my app means. We can now finally send this service.yaml file to the API server. We will do this by using the kubectl apply -f, and then we will specify the YAML file. I'll hit enter. It says that my app services has been created. So now if I do kubectl get svc, I now have my app service. The type is node port, and then as you can see, I have port 3000 mapped to port 30050. So now I should be able to connect to the Node.js application using this port. If I do kubectl describe service, the ingress load balancer is basically localhost. So if I go on localhost port 30050, I'm sure that I will be able to access the Node.js application and see hello world in the browser. So I'll go to the browser, and then over here I'll put the port and I'll hit enter. And as you can see, it says hello world. So we have successfully been able to deploy our application using Kubernetes. We are able to manage our application using Kubernetes because we are able to scale up and down. Lastly, we are able to connect to our Node.js application inside of the Kubernetes cluster. That is all I wanted to share with you guys today. Thank you guys for watching, and I'll see you in the next video tutorial.